This is the third tutorial video on the bonus project for the food drive. In this video, we're going to answer the question, determine the mass of water that could be heated from -5 to 5 degrees Celsius by burning a 100-gram sample of the food. So remember that you need to use a different food for each of these three calculations. So whatever food you used in the last part with heating the water by 5 degrees Celsius, you should use a different food for this part. So I'm going to use chicken noodle soup for this part. Now, again, like the last part, it says that we want to burn a 100-gram sample of the food. So I found in the conversion part of this project that chicken noodle soup, 460,240 joules. So this was my conversion from 110 food calories. And the serving size for chicken noodle soup was 242 grams. So now what I need to do is I need to set up a proportion to figure out how many joules would the chicken noodle soup have if it were only 100 grams. So now I'm going to use my calculator and I'm going to solve this proportion. So here's my number of joules for 100 grams. So remember that if I had 460,000 for 242 grams, I should have less than 460,000. I should have just less than half because 100 grams is just less than half of 242. So here's my amount of joules for 100 grams of chicken noodle soup. Now based on this value for my heat, for my joules, it says that we're heating water from -5 to 5 degrees Celsius by burning a 100-gram sample of food. So this value is my total heat, my total Q. Because water will be going through a phase change, we actually need a heating curve. So I'm going to start at -5, I'm going to go to 0, and I'm going to go up to 5. So what happens at -5, from -5 to 0, is that we're actually heating the solid water. So we're heating the ice, we're increasing the speed of the solid water molecules. At 0, it melts, and then from 0 to 5, we start heating the liquid. So from -5 to 0, that'll be Q1, we have a delta T, 0 is Q2, and from 0 to 5, that's Q3, we're gonna have a delta T again. So to figure out our Q total, we're gonna have Q1 plus Q2 plus Q3. Now Q1 and Q3 will be calculated in a similar way. Q1 will have MC delta T. Q2 is gonna be calculated a little bit differently. That's M delta HF. So this is mass times the heat of fusion, because it's melting, that's synonymous with fusion. And Q3 will also be MC delta T. Now the difference between Q1 and Q3 is the value of C. The value of C is different for each of them. Q3, it's 4.184 joules per gram degree Celsius because this is liquid water. Q1 is the specific heat for solid water, which is ice. The specific heat for ice is 2.03 joules per gram degree Celsius. Now our delta T, remember to calculate delta T, it's final minus initial. So you have to be careful with Q1 because it's 0 minus -5. Q3 is 5 minus 0. Now this is going to be calculated a little bit differently because we're solving for M and we have our total Q. So what I'm going to do down here is I'm going to set everything up. I have 190,181.8 joules. That was the value that I got for 100 grams of food. And I'm going to plug in as much as I can. So I have M times 2.03. My delta T for Q1, again, is 0 minus -5. So that's 5 degrees Celsius, plus m times delta HF. I don't know m, that's what I'm solving for. The heat of fusion, if you look back at your notes, is 334 joules per gram. So this is all thermochemistry. So 334 joules per gram, plus MC delta T for liquid water. Again, I don't know m. C is 4.184. Delta T is 5 minus 0, which is 5. Now your goal here is to solve for m. So what I can do is I can actually multiply all of this out, and I can divide and solve for m, or you could actually factor an m out. So what I'm going to do is I'm going to actually go ahead and I'm going to multiply each of the values, and then I'm going to combine like terms. So what I did here is I actually just multiplied 2.03 times 5, 334 just came down with the m, multiplied 4.184 and 5, and notice now I have all these values of m. So I can add these together, combine like terms, divide it over, and that gives us our mass in grams.